Okay, everybody, thanks for your patience. We're just getting a couple of little technological things worked out, some of which I wasn't able to work out. I can't get the overhead thingy to turn on, so we just won't have any sleepy PowerPoints tonight. You will have to exercise your wrists a lot more. Yeah, I'm not sure why I couldn't get that to turn on.
I think someone stood up for the manual and off, actually. We've done that in class. Last year we did that.
Do you have extra paper if I need any? Yeah. I don't need any right
But I probably, I probably have lots that I could tell you and then just show the PowerPoint stuff when we get to the other room.
You can edit it into. I don't know how to sit. Actually, add another 2 days.
It's like sit and take notes or sleep.
Yeah, we might pause, as I was explaining to Allison, we might pause in between to kind of, what? Yeah, we're for a commercial break, to swap cameras, because if I have two different kinds of cameras, one that uses a tape and one that has its own internal hard drive. So if I record on, alternate recording on the two of them, that means I could upload the footage on two different computers at the same time and cut the time for uploading in half, right? So,
Fancy.
yeah, it pays to have lots of laptops.
She's got like 10 MacBooks. It's crazy.
But you have to pay to have one.
Not unless you're an intern.
All right, so, I guess I wanted to start off by just talking about something that came up in office hours in relation to the last stuff that we did, I think. It's kind of a blur to me now. When we saw each other last, what was office hours, what was class, and that just rhymed, but it's not just for the camera. Yeah, when we discussed the reactions of ethers with hot concentrated peracids, like periodic acid or perbromic acid, iodic acid or bromic acid, right? HBr or HI. We're talking about the possibility encountered when you have an ether like this one. Did I talk about this in lecture? Office hours, right?
No, it's a little bit of lecture.
Or do it now.
But did I talk about it in lecture after we talked about it more in office hours? We had workshops, so when we had office hours, we had workshop. Okay, yeah, so I'm right. All right, so I'm gonna put this as generic HX. So we know HX could be HBr or HI usually. Normally you wouldn't use HCl or HF because you depend on the acid to be a strong acid to protonate the ether first. But then the anion, that's the counter ion of that acid, must also be a good nucleophile to attack and do the displacement if it's an SN2 type of thing, or add to the cation if it's an SN1 type of thing, right? And that's what we encountered with an ether, something like this one, where we know that the first thing that would happen would be protonation of the ether oxygen. To form this oxonium species. But what came up to be of interest, what I tried to present to you in class, but it might not have been as clear as I would have liked it to be, is that two things could possibly happen once you have this oxonium species, right? So the first, and I'm just gonna kind of draw it twice so that can look at the two things side by side. So the first thing, which would resemble what we had done previous to this, is that this anionic thing, which is also a good nucleophile, can do an SN2 type of attack to kick this positive part out as a leaving group. So if you use just 1 molar equivalent of your HX, you would get this alcohol at that stage, plus that alkyl halide, whatever that is. So now, if mechanistically this does something different, which it can do, because this alkyl part of the ether would now be stable enough as a carbocation for that to happen under these conditions, because we're using concentrated HX and heat, right? So those are conditions under which you could expect carbocations to form. And so that could happen, in which case you could get that alcohol plus that cation, and then your X minus could add to that cation. So the alkyl halide that you form would be that one. So the point to this is that you probably would have both things going on at the same time, okay? You'd probably get some of this kind of SN2 type of process happening at the same time that you might get some of this type of thing happening. So if you use just 1 molar equivalent, you might end up with a mixture of all 4 of these products, right? And what I try to bring up in office hours is that, you know, the product ratio might vary depending on what X is. So the rationale for that is that if X is a really good nucleophile, then this SN2 type of process would probably work more efficiently. Whereas if X is not so good a nucleophile, then you would have more of a chance for the carbocation to form, and so this process might be more favored. So for that reason, I would say even in going from using HBr to HI, we might see a difference in the product ratio, which would be dependent on the difference